Hello, I'll be discussing IMAPS and DNS, covering their roles, configurations, and best practices. This presentation will help you to understand how these protocols work, why they are essential, and how to implement them securely in various environments. By the end of this session, you'll have a comprehensive understanding of how IMAPS secures email communications and how DNS enables seamless internet navigation. IMAPS, which stands for Internet Message Access Protocol Secure, is a secure version of IMAP utilizing SSL and TLS encryption to ensure secure communication between email clients and servers. Unlike POP3, which downloads emails to a local device and removes them from the server, IMAPS allows messages to be accessed and managed directly on the email server. This means that users can check their emails from multiple devices such as smartphones, tablets, and computers, while ensuring that all messages are synchronized across these platforms. One of the key benefits of IMAPS is that it prevents email data from being altered or intercepted during transmission, because emails often contain sensitive information. Encryption is crucial in preventing cyber threats such as man-in-the-middle attacks. IMAPS commonly operates on port 993, which is the designated port for encrypted IMAP traffic. By utilizing IMAPS instead of standard IMAP, users and organizations significantly reduce the risk of unauthorized access and data breaches. Setting up IMAPS with Dovecot involves several critical steps that ensure a secure and reliable email server. Before configuring the mail server, it is essential to establish the correct DNS records. These records, which direct email traffic to the appropriate mail server, properly configured records ensure that incoming emails are routed correctly. After that, you would install Dovecot, which is a widely used open source IMAP server that provides high performance mail delivery. Installing Dovecot on a Linux-based system such as Ubuntu is a straightforward process. After that, users need to be created and assigned email addresses. These users will authenticate with the server to send and receive emails. Lastly, adjusting firewall rules is crucial in ensuring only authorized access to the IMAPS port 993. Firewalls should be configured to allow connections only from trusted sources, blocking unauthorized attempts to access the server. To enhance IMAPS security, consider implementing the following best practices. The first one being using strong encryption ciphers and protocols. Ensure that only the latest and most secure TLS versions are enabled to prevent vulnerabilities. Second, implement firewall rules to restrict access. This means use network security policies to allow only necessary IP ranges to connect to the IMAPS server. Third, configure Dovecot to limit login attempts. By setting up rate limiting, failed login attempts can be restricted, preventing brute force attacks. And lastly, enforce client certificate authentication. This adds an additional layer of security, ensuring that only authorized devices can connect to the mail server. Now let's talk about DNS, or the domain name system. DNS is a fundamental component of Internet infrastructure that translates human-readable domain names such as example.com into machine-readable IP addresses like 192.123.45. This process allows users to access websites and online services without needing to remember complex numerical addresses. DNS operates in a hierarchical manner with different levels of name servers handling various aspects of the lookup process. The primary components include root name servers. This is the highest level in the DNS hierarchy, which directs queries to appropriate top-level domain servers. TLD servers, or top-level domain servers, handle domains with specific top-level domains such as .com, .org, or .net. And then authoritative name servers contain specific DNS records for a given domain and provide the final resolution of an IP address. Without DNS, Internet users would have to memorize IP addresses for every website that they visit, making the browsing experience very inefficient. To configure DNS on an IIS server, you should follow these steps. Install the DNS server role. On Windows Server, enable the DNS server role through the Server Manager tool. Second, configure the DNS server settings. Set up key configurations such as root hints and forwarders to optimize query resolution and improve performance. Third, create DNS zones. Define primary and secondary DNS zones to manage domain name mapping efficiently. And then last, test name resolution. Verify that the DNS server correctly resolves domain names to IP addresses. For Linux-based systems, Bind is a widely used DNS server that provides robust domain resolution services. The configuration process includes installing Bind, use package managers to install Bind on the DNS server. Second, configure primary and secondary DNS zones. Set up authoritative zones to maintain domain records and define backup name servers. Third, set up DNS clients. Configure client systems to use the DNS server for name resolution. Fourth, test DNS functionality. Run tests to ensure that DNS queries return the correct IP address and that name resolution works as anticipated. And then last, manage DNS records. Keep DNS records updated and ensure they follow best security practices. To maintain a secure DNS environment, it is recommended to follow these best practices. The first one being limit dynamic DNS updates. Prevent unauthorized updates to DNS records by restricting who can make changes. The next recommendation would be disable recursive queries. This reduces the risk of DNS cache poisoning attacks where malicious data is inserted into the DNS cache. Third, restrict zone transfers. Only allow authorized servers to perform DNS zone transfers to prevent data leaks and unauthorized replication. And then lastly, implement DNSSEC. DNS security extensions provide cryptographic verification of DNS records, preventing spoofing attacks.